Hello again. So here I am after we had an unexpected internet disconnection, and I promise to continue the little that we still have through an recording alone offline. Okay, so let me tell you what we were doing. We were actually doing the electric field mapping, the theory, or actually we're done with the theory, and we were discussing the lab report. As you can remember, we had four parts. Let me show you. So the lab was made of part one, two, three, and four. Part one, you were given a capacitor, the distance between the plates of which is a variable. Effect of the dielectric material, this is where in part two you were supposed to insert a dielectric, remove the dielectric, and find or measure the capacitance before and after, or with and without the dielectric. And by finding the ratio, you can find K, the dielectric constant. Then you were given a box of capacitors. I'm going to show you in a minute in the video in a moment how the box looks like and how the connections will be made. Your job was basically to compare your calculation to the measured values given by me. Okay, and eventually we had part four, coaxial cables. So let me start directly with part four. Coaxial cables, what are they? They actually look like this, and I'm sure you saw them somewhere around the house. So these are cables where you have an outside cable and an inside cable. You see the copper wire? Let me get a pen. So basically, this is the inside copper wire, and this is the outside copper mesh. In between, you have an insulator, and outside, you have an insulator as well. All right. So instead of having two cables separated to be connected to the positive terminal and the reference terminal, you will have two cables, yes, but coaxial, like one inside and one outside. They will act like two parallel plate capacitors, but the plates are not flat, they're not a square, they're not a rectangle, they're actually a disc. Okay, so you are given the small radius I, the big radius B, and the length of the wire. What is C? C is the capacitance of your cable. L is the length of the cable. K is the electric constant between the two cables. B and A is the ratio between the different radii. All right. Let me show you now how the lab report looks like, because you need to understand what to expect. And this is our lab report. I'm gonna go directly to our table of contents and click the electric constant. Okay, so what do you expect? You will measure, or I will measure the length of each cable, length 1, length 2. I'm going to give you a value in centimeter or millimeters or basically meters. You will guess the uncertainty from the video and you will round your value accordingly. Capacitance of the adapter. For me to be able to plug the cable on my LCR meter, I need an adapter, and the adapter looks like this. You're gonna definitely see it. So this is your LCR meter, and it has two terminals. The adapter looks like this. Let me use green. It is basically, it has two legs, and then from the other side, it has a BNC connector. So basically now you can connect your BNC directly to the adapter. So in other words, you were supposed to take the capacitance of the adapter without the wire, and then with the adapter, because what this is what you measure, and minus the adapter from it. Okay, then you repeat for cable 2 and minus the adapter from it, because you don't want to measure the capacitance of the adapter itself. And eventually you're supposed to connect cable 1 and cable 2 together. So you have cable 1 and eventually cable 2, all right, together to be able to measure the C equivalent. The question is, are they connected in series or in parallel? If I have a cable as such and I connect to it another cable, coaxial cable, connection and connection, do you think this is a series or a parallel connection? The best way to tell is to compare C equivalent to C1 and C2. If they're the sum, it means they're in parallel. If the inverse, is equal to the sum of the inverse, this would mean that they are in series. So this is what you're supposed to say. Are cable 1 and cable 2 in their last configuration connected in parallel or in series? Justify your answer, definitely using your data. Find the dielectric constant K of one of the cables. You are given B over A. Can you tell what is the dielectric material inside the cable? So you have the length, you have A over B. You take one of the cables, you find K. The cables are supposedly made of the same material, so it doesn't matter. And you try to guess. So you go online, get some dielectric constant, and try to guess, is that this K would mean that you have, I don't know, cardboard inside, you have, I don't know. So try to find whatever list you can find. And it doesn't matter what you will find, it's only for you to make use of any measurement or result you will get. Okay, so this is basically part 4 that we missed. Before the end of the presentation, I wanted us to discuss a bit how to do the plot. Let's say they ask you to plot C versus 1 over D. Which is X? Which is Y? On Excel, do you put X first or Y first? Think about it. And in this case, X is 1 over D. Are you supposed to calculate 1 over D first before you plot? Do linear regression to find the slope. I believe you simply need to plot, right click, insert scatter, right click, add equation, I don't know. By simply showing the equation, you can tell the slope. Find the error on the slope. I believe you guys know how to do this. I challenge you to start trying the linest function. You have a video uploaded in our first data analysis folder. How about you take some time this week to try it? If you don't know how to try it, you can also refer to me. I think it's worth it, so you can learn how to do it, okay? Now, if I need to move to the equation, to the experiment, in the first part, I'm showing you the equipment. This is the capacitor, parallel plates, separated by a distance D. This is the LCR meter. Let me move slower. You can see this is a DMM, digital multimeter, that will not measure the capacitance, and I don't need it. I think it was on the bench by mistake. These are the dielectric. You can see they're very thin. I'm gonna insert one of those between the plates. These are the cables I'm gonna use. And this is a special cable for the LCR meter because it has one side banana, one side crocodile, so I can pinch them to my to the plates of my capacitor. And these are the BNC cables. Now I'm gonna use the banana crocodile cables to connect them to my capacitor. Now I'm fixing the bench. I'm showing you how to do the connections, and I'm showing you basically that the cables, they do have a capacitance before you do any connection, and I'm supposed to minus this answer from my measurements. Okay, how about you do the reading alone? Do you think it's reasonable? The black wire to the second plate. So make sure you minus this value from your measurements, okay? Now, all right, so the value is not visible. I'm gonna give it to you and you minus it from your measurement. Now I'm showing how the connections are made and probably some idea about the order of magnitude of the value. Yeah, something like 8.7. I don't know if this is 13, 19, depending on the distance. And I'm gonna vary the distance between the plates. Okay, yes. Okay. This is another view from my camera to show you how I do the experiment with and without the dielectric. So with the dielectric, without the dielectric, without moving the distance between the plates. And as you can see, I closed the two surfaces, the two plates, enough not to squeeze the dielectric a lot, but simply to close on it, okay? Yes, so this is experiment 2. Now let me see if experiment 3. So this is experiment 3. You have a box of capacitors. I think I'm gonna pick only the first 3. And let me show you how I do the connections to measure C1. And then how to do the connections. And this is the nominal value. Nominal value is what is written on it. And experimental value is what you measure from the LCR meter. And here I'm gonna measure the next one probably, and then the third one, and then I'm gonna connect them in series. This is a series connection, okay? Because yeah, so you see they're connected together, and probably I'm gonna show you a parallel connection. This is a parallel connection. You see those two are connected together. Now I'm gonna take the LCR meter and put on top. Yes, yes, and do the measurements. Oh, now we are in part 4. I show you the cables. You see the adapter. Wait, yeah, yes. Okay. This is the adapter. It goes inside the red and black terminal, and it has an adapter that is BNC that could be connected to my BNC cable. Okay? You see how long the cable is? I should make it as long as possible because I don't want the plates to be closer than they should. And I'm gonna measure, okay, with and without the adapter for me to be able to minus the value. You see the value of the C of the adapter is very visible. Probably I'm gonna ask you to read it from the video. I'm gonna check this out. I already sent you the results, so forget about it. Yes. Okay, if the results I sent you are a little bit different than those, don't worry. Okay, take whatever results I give you. Probably the results were made on a different adapter, I can't remember. And in this case, I just wanted to make sure the cables are long enough before doing the measurements. And that's it for the experiment, you see. So I hope this tiny appendix I gave you or extension to our recorded session will be beneficial for you. All right. In case you still have any question, please let me know. Don't wait. I'm willing to meet with you on a daily basis. Don't forget that. Have a nice evening.